Welcome to this predicted paper from OnMaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our OnMaths site. OnMaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. For us to create the largest number, we need to pick the biggest digits for the start of the number. So the biggest digit is 7, then 6, then 4, then 3. But the question says it wants the largest even number, so we need to just swap the last two around to make sure that it is even. So our answer is 7,634. So with this question, we need to first of all count how many sides this polygon has. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10 sides. And we just need to know that a 10-sided shape is a decagon. Now we are expected to know all of the names of shapes between 3 and 10 sides, so if you don't know them already, just sit down and learn them. There are 10 squares in total, so each square is worth 1/10. And if we count all of the shaded squares, we notice that in total there are 7 shaded squares, so that's 7 lots of 1/10 or 7/10. All angles around a point add up to 360 degrees. So we've got this angle here, which is 25 degrees, and we've got this angle here, which is currently unknown. So to find out what A is, we're going to take away that 25 from 360. And when you do that, you get 335 degrees, which is our answer. You'll often need to write down the reason, which is angles around a point add up to 360 degrees. To work out a perimeter of a shape, what I do is I pick a point on that shape and add up all the lengths as I go around the shape. So I'm going to do 15.3. So the perimeter is 15.3. And we're going to go down the next side, down here. Now it doesn't actually tell us what length that is, but a characteristic about a rectangle is that the opposite sides are equal. So this is going to be 9.3. So we're going to add the 9.3. Then I'm going to go down this side here. And again, the opposite sides are equal. This is also going to be 15.3. So we're going to add that. And then finally, we go up the last side. So we return to where we got up to, or where we started, and that's 9.3. So when you add those up, you get 49.2. And the units will be centimetres, because all the units on the diagram are centimetres. Often people forget that it's not an area, it's a length, it's a distance. If I have walked that, I've walked 49.2 centimetres, although I'd have to be very small to be able to do that. To find the factors of 30, we're just going to write down all the factor pairs, or all the pairs of numbers that multiply together to make 30. So 1 times 30 is 30, 2 times 15, 3 times 10. Now 4 doesn't go because 30 is not in the 4 times table. 5 times 6, and we notice that if we pick 6, it's just going to be 6 times 5, it's just going to be the opposite. So the factors are all the numbers that we've just written down. So it would be 1, 2, 3, 5, 6, 10, 15, and 30. Whenever we multiply two negatives, we always get a positive, so we know our answer will be positive. We're going to do 9 times 12, which is going to be 108. And v times v, which is going to be v squared. So 55% is the same as 55 over 100. And what I can do is I can divide top one of the fraction by 5. And so that is going to equal 11 over 20. Now in total there are 20 squares here because there's 5 across and 4 down. 5 times 4 is 20. And if there's 20 squares and we're looking to shade in 11 20ths, it's just going to be 11 squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. To find the fraction of an amount, what we do is we divide by the bottom of the fraction and we times it by the top of the fraction. So the first thing we're going to do is 100 divided by that 5, and that would be 20. Then we're going to get that 20 and we're going to times it by the top of the fraction. So 20 times 4 is 80. So our answer will be 80 centimetres. Something to realise in this table we're given in this question is that the triangle has 3 sides, quadrilateral 4, pentagon 5 and hexagon 6. And that number is just 2 less than the number of faces. So basically if you've got the number of sides, you add 2. So 4 plus 2 is 6, 5 plus 2 is 7, and 6 plus 2 is 8. So if we've got 20 sides, and we just do the same thing, so we're just adding 2, then we should have 22 faces. So our answer is 22. The range is the biggest number, take away the smallest number. The biggest number in this stem-leaf diagram is found at the bottom right. So this 9 here represents 69. So it would be 69, take away, and the smallest number is always at the top left. So this 4 here represents 34. So it would be 69, take away 34, which is 35. When a number is times by itself twice, we write it as 3 squared, or that number squared. When it's times by itself 3 times, we do 3 to the power of 3, or that number to the power of 3. So when we've got something times by itself 4 times, it's just going to be that number to the power of 4. So we're going to first of all work out what 100% of 260 is, and that's just 260. Next we're going to work out what 10% is. And 10% is very easy because we just divide it by 10. So 260 divided by 10 is 26. And we also need a 5, so I'm going to try and grab a 5%. And we do that by halving the 10%. So that would be 13. And then all we need to do is add the 26 to the 13, because the 10 plus the 5% are 15. And that's 39. So our answer is 39. So BidMaths tells us we need to do the indices first, and then we do the adding. So we go to the indices. 12 squared means 12 times 12, and that would be 144. 6 squared means 6 times 6, which is 36. So we're going to do 144, the 12 squared, plus the 6 squared, so plus the 36, and that will be 180. So the first thing we're going to do is write this as a ratio between the fractions. So we're going to have green to black. Now it says that a quarter of the counters are black, and therefore the remaining counters will be green. So if a quarter are black, that leaves 3/4 to be green. And what we can do here is on both sides of the ratio, what I'm going to do is just times it by 4. So I'm just going to times 4 both sides. So 3 divided by 4 times 4, because over 4 just means divided by 4. So 3 divided by 4 times by 4 just gets rid of the fraction. And 1 divided by 4 times 4 is just going to be 1. Now this might surprise some people because they will probably think it's a ratio of 4 to 1. But we can show here that it's a ratio of 3 to 1. These fractions have different denominators, so we need to make sure they're the same before we can add these fractions. So we've got 15 and we've got 10. So what we can do is just quickly write out the 15 and the 10 times table. And we don't have to go very far before we realise that 30 is in both of them. So we need to get the bottoms of these fractions to 30. So for 2 over 15, all we do is we times top and bottom by 2 to get to 30. So it becomes 4 over 30. And for 3 over 10, we just times top and bottom by 3, which would make 9 over 30. So we can rewrite this question as 4 over 30 plus 9 over 30. When the bottoms of the fractions, the denominators are the same, we just add the tops, we add the numerators. So that would be 13 over 30. Can we simplify it? Well, 13 is a prime number and 13 doesn't go into 30. So our answer is 13 over 30. So to do this question, you just need a piece of paper, a ruler and a protractor. And the first thing we do is we draw the 11 centimetre line. And my one will not be 11 centimetres for you. It is on my screen. But because depending on what device you watch this on will change obviously its length. And what I'm going to do is I'm going to put my protractor on this end here. So I've kind of got my protractor here. And I'm going to just have a look at getting 39 degrees. Now you've got to be careful because 39 is on the inside, and I'm just going to do a dot. So always look to see which one, the inside or the outside of the protractor, starts at 0, and the inside should start at 0 from this side. And I'm just going to draw a line that connects the end of that line and the dot. Like so. Now just you can keep it going. Right, the next thing I'm going to do is put my protractor on the other side. So my protractor is kind of here. And I'm lining up the crosshairs with this point here. But this time I'm measuring on the left hand side. And I'm looking at 59 degrees, which will be here. Get my ruler. Now this time I can actually stop where it hits the other line. So keep going and then stop where it hits the other line. This screen's not perfectly calibrated, so it's difficult to do precise work, something like that. And then what you can do is you can get your rubber and just rub out the extra bit of line that we had to do. And so this is our 39 degrees here, and you don't need to label this on the diagram, but just so we know what we're doing. And it says when it's completed, measure length x. So I'm going to get my ruler out and I'm going to measure this length here, this one here, and it is about 95 millimeters. So the answer for me is 95 millimeters. Now there is some level of precision. You're not going to get necessarily exactly 95 millimeters. When we mark these questions, we normally have an overlay and we put it over the top, and if it's roughly the same, and you can make small errors because nobody's perfect, and my diagram definitely is not perfect, but there are allowable small errors here and there. So with a stem leaf diagram, the numbers in the middle often represent tens. They could be units. So we look at the key first of all, and we see that 3 line 9 means 93. So the numbers in the middle are going to represent 10. So this is a 90. Now we're looking for English, so this will be 92. So our first number will be 92. Then this will be 10 tens and a 4. So it would be 104. 11 tens and 1. So 111, and then 11 tens and 2. So to find the median, we go cross out the biggest and smallest until we're left with 1 or 2 in the middle. Here we're left with 2. So what we're going to do is we're just going to add the 104 to the 111, and we're just going to divide that by 2. So when we do that, we get 107.5 or 0.5. So our answer is 107.5. So 100% of 120 is 120. And let's put that in a bubble. So we're going to split that bubble up to find out what 10% is. And to find 10%, all we need to do is divide it by 10. So divide 120 by 10, you get 12. And then we want to split that bubble up again into 5%. And 5% is found just by halving it again. And so that would be, or just halving it, so that would be half of 12, which is 6. We could do with 1% as well. And we're trying to get to 26%, so we'll do 1%. So dividing the 10% by 10 again, 1.2. And we could do with 20%, and 20% just means we're going to double the 10%. So double 12 will be 24. So to work out 26%, we need to add these together to get to 26. So we're going to add these numbers here together. Okay, so we've got a 6, a 1.2, and a 24. And we're adding them together. And that would be 11, so carry the 1, that would be 3. Now, it says to decrease it by 26%. So 26% is 31.2. So we need to subtract that. So we're going to do 120, take away 31.2. So I need to borrow 1 from the 2 to make that a 10, borrow 1 there to make that a 10, and that would be a 9. So 10 take away 2 is 8. 9 take away 1 is 8. And there's a 1 here, so we need to borrow that 1. That's 11 take away 3, which is 8. So our answer is 88.8. To find the surface area of the cuboid, I'm just going to label the faces and do them individually. So we've got A, which is 24 by 13. So we're going to do 24 times 13, which is 312. Next we're going to do B, which is this one at the top, and it's 24 across and 8 is the length. So 24 times 8, which is 192. And finally C on this side here, which is going to be 13 times 8, which is 104. Now notice that the faces all have the exact same face on the opposite side. So this one at the back is also A, this one at the side is also C, and the one at the bottom is also B. So what I'm going to do is add up all the areas of the squares and double it. So to work out the surface area, we're going to do 2 times and then 312 plus 192 plus 104, and that will give me 1,216 centimeters cubed squared, because it's an area. So we can quickly draw a line of best fit for here, and it looks something like that. And if our line of best fit is increasing like we have here, then we say the data is positive. If, however, the line of best fit is decreasing and looks like this, we say that it's a negative correlation. So positive if it's going up, which this one is, so it's a positive correlation. And if it's going down, then it's a negative correlation. If the data is all over the place, so it looks like something like this, where you've got the points everywhere, we say that's no correlation. So whenever we have a scatter graph, chances are we'll be drawing a line of best fit. And so that's what we'll start off with, draw a line of best fit in. And it says we're looking for a height of the box, or an estimate of the height of the box with the width of 17. So 17 is here. So the width of 17 will be a line across. Let's try and get this just right. Line across there. And what we do is we draw a line down when it hits the line of best fit. Now looking at the scale here, this seems to be going up in 2s. And so this line here would be at 3. Here we're given angles on a parallel line, and the first thing I do is just find out what letter they connect with. And if you look, this is kind of like an upside down F, so they're F angles, and F angles are always equal, so X is going to be 11 degrees, that's the easy bit. Difficult bit is figuring out Y, and the way I remember it is that cor F bonding, and I just put the F in there, so it's going to be cor F bonding is what's in my head, but what I write down is obviously cor S bonding angles, but it's just a way that I have to remember it. Bearings are always from north and go clockwise. So let's have a look at where the north line is. Well, the north line is here. And to find the bearing of B from A, so that means we're at A and we're looking at the angle of B, we're going to go clockwise, and you can see on the diagram it's already labelled as 42 degrees. But the third rule of bearings is they must be 3 digits. So instead of 42, it's going to be 0, 4, 2. Mode just means the most common or most frequent, and modal is exactly the same. It's just the most frequent amount of coins we're looking for. So the students who had 3 coins in their pockets came up 15 times. Students had 4 coins in their pocket, well, there were 16 of them. There were 15 students who had 5 coins, 17 students who had 6 coins, and 12 students who had 7 coins. So the most frequent amount of coins a student has in their pocket will be 6, because it happens 17 times, which is more than any other amount of coins. To multiply fractions, all you need to do is multiply the tops. 3 times 7 is 21, and multiply the bottoms. 4 times 11 is 44. We see whether we can simplify this, but actually there's no number that goes into 21 and 44, so it's 21 over 44 is our answer. So we're going to write an expression for the amount of people on the first bus. So they've started with X passengers and they've gone to 11 bus stops with X passengers. So altogether that is 12X. So we're going to have the first bus, and so we've got 12X. And then on the last bus stop, 19 passengers get on, so plus 19. Now for the second bus, well, we start with X, and a further 5X come on, because 5 bus stops with X passengers, so that's 6X altogether. And then 79 get on. And it says the first bus finishes with less passengers than the first. So the first bus finishes with less, and the way we show that is with this inequality here. Now all we need to do is solve that inequality, and we've got X on both sides, so we look at the X's. We've got 12X and 6X, so we always take away the smaller amount, so we're going to take away the 6X both sides. And next thing we're going to do is take away the 19 from both sides. And so, meant to be 60. Got ahead of myself. And the last thing we do is divide by 6 both sides. And so we've got X is less than 10. Now, it says here, assuming no passengers got off either bus, what is the largest value for X? Now it is tempting to write down 10, but it says X has to be less than 10. So the biggest number we can get that is less than 10 is 9. So for this question we need to understand the different types of graphs from different functions. So if we have a reciprocal graph, it looks something like this and like this. It could be the other way around, and it could be distorted, but it basically goes down to a point along here. It goes to infinity, and it goes to infinity along a point over here. And obviously those positions could change. Then we've got a linear graph. A linear graph is just any straight line, so just any kind of straight line, either up or down. And this doesn't look like either of those. Then we've got a exponential graph. An exponential graph just starts really small and then just really increases like that and just keeps going up. And here we kind of have that, obviously the other way around, it starts going down, but here it's actually going up, so it can't be a reciprocal graph. So the graph that this is, or could be, is a quadratic graph, because it's a nice U shape. So if we carry this on, it could be a nice U shape. It could also be a cubic graph as well. So it could go up and then down and then up, and that's a cubic graph. But the most obvious one is a quadratic graph. So quadratic function. So when we say y is directly proportional to x, what we mean is whenever x doubles, y will double. Whenever x halves, y will halve. Now we've got this proportionality sign here. And to make that an equals, all we need to do is introduce a k constant to the right hand side. So it's y equals something times x. Now to find out what that something is, to find out what that constant is, what we're going to do is feed in the value of y and the value of x that we have. So we're going to feed those in. So y is 55.3 and x is 7. So it would be 7k. And we're just going to put our lines in and solve this. So it's going to be divide by 7 both sides. And 55.3 divided by 7 is 7.9. And that's what k is. So we're going to rewrite this equation here, this formula here, y equals 7.9x. And that is actually our answer. So Pythagoras says that a squared plus b squared equals c squared. And the c is the one opposite the right angle. So I'm going to label this a and b. So it would be 5 squared plus 12 squared equals c squared. 25 plus 144 is equal to c squared. And then 25 plus 144 is 169. And then we're solving to find out what c is. And we're just going to square root both sides. So square root of 169 is 13. So c is 13. So the symbol here basically means and. And the way I remember it is if you draw that symbol and just put a line through it, you can make the word and. So we're looking at the probability of getting something that is in A and C. So the only ones that are in A and C are this 8 and this 9 here. So we're going to just add the 8 and the 9 together, which give us 17. Now we need to then work out how many numbers there are in total, so that's all of them. So 4 plus 8 plus 9 plus 5 plus 8 plus 3 plus 11 plus 6. So we need the total, which is 54. And then we get the 17, and we put that over the amount in total, so over 54. If I start by drawing a number line, and we're going to put the 110 in the middle. Now I'm going to label the next one down and the next one up. It says to the nearest 10, so the next one down would be 100, and the next one up would be 120. Now we're interested in the cutoff, and the cutoff point is between the two numbers. Okay, so that's the cutoff point. If it goes above that cutoff point, it would have rounded to the next number up. So if the number was here, it would round to 120. If the number is on the cutoff point, which we can see is going to be 115, then we know it would round up. So we need to find the biggest number in this part here. So this part here, and it includes this line actually, so it includes this line. So all the numbers that would have rounded to 110 would have been 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, which would be here. But if it was 115, it would have rounded to 120. So 114 is the biggest number it could have been before rounding to 120. And we know it didn't round to 120 because in the question it says it's 110 to the nearest 10. So our answer is 114. So to find the area of a rectangle, we do length times the width. So here, to find the area, we will do the 10 times the whole of the 10t plus 4. And to show that we're doing the whole of it, we put it in brackets. So a different way of writing that is 10 brackets 10t plus 4. And whichever method you use to expand brackets, feel free to do it here. I'm going to just do the grid method, but whatever method you prefer. Actually, I don't need the, I've done too many here. Let's get rid of that. So we've got 10 times 10t plus 4. So and we're timesing them. So 10 times 10t, 10 times 10 is 100. So it'd be 100t. 10 times 4 is 40. So our answer will be 100t plus 40. To find the pressure, we need the area and the force. And we're given the force in the question, and so all we need to do is find out what the area is, which will be the 7 times the 9, which will be 63 centimeters squared. And the force is given to us in the question, so what we can do is write down the pressure formula, which says that pressure equals the force divided by the area. Force is given to us as 2268. The area we've calculated is 63. Divide the 2 and you get 36. So it's going to be 36 newtons per centimetre squared. When working out if two triangles are congruent, which means they're the same, you can either have RHS, which is a right angle hypotenuse side. You can have 3 sides that are the same. You can have 2 angles then a side, or an angle then a side then an angle, or you can have a side then an angle then a side. In this question, we have a right angle. We only have 2 sides, so we can cross this one out. And if you look, that the 2 sides are next to each other, then the angle. So it's ASS or SSA. So these don't really fit, but the angle is a right angle, so we've got a right angle on both of them. We have the hypotenuse, and we have a different side that are all equal. So the proof here is RHS. To rearrange this, I'm just going to write out the equation again. And I'm going to put my lines in. Okay, so the first thing I'm going to do is try and make the x positive, because we're looking to make x the subject of the formula, which means we need it to be x equals. So what I'm going to do is just add x both sides. So we've got x plus m equals 10. Then we want to get rid of anything on the left hand side that's not this x. So we want to get rid of this plus m. So we're going to do that by subtracting m both sides. So we've got x equals 10 minus m. So our answer is 10 minus m. X equals 10 minus m. So you can see here that the triangle has changed size. So the transformation we're looking at is an enlargement. And we need to find out how much it's changed by, so what the scale factor is. And so we've got 2 at the bottom here of triangle A, and we've got 4 at the bottom here of triangle B. And so we are going to times the 2 by 2 to get to 4, so the scale factor is going to be 2. And last thing we need is the centre of enlargement. And to do this, we're just going to connect all of the vertices, all the corners of the triangle, with straight lines. Make it as precise as possible. And we've got the bottom left corners as well. And these are just going to be straight lines, aren't they? And we've got the bottom right ones as well, which will just be a straight line going the other way, if I get it perfect. There we go. And so where's the point they all cross? Well, they all cross at this coordinate here. And that is going to be our centre enlargement. So the centre enlargement is going to be at 3 minus 4. So angles and a point add up to 360, and we are given the values of the angles, but in terms of r. So we know that r plus 9r plus 20 will equal 360. So we've got an equation here we can solve. So first of all, let's add the r's together, and so that will be 10r plus 20 equals 360. Then we're going to subtract the 20 from both sides. So we have 10r equals 340. And then we're going to divide by 10 both sides. So we have r equals 34. So our answer is 34. Whenever we do these kind of questions, it's always best to convert the pattern into numbers. So we're just going to count the dots. So we've got 2, 4, 6, 8, 9 in the first one. 2, 4, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So our sequence is going 9, 13, 17. And we're going to see what it's going up in. So we're adding 4 each time. And that means our sequence will involve 4n. And then what we do is we go backwards 1 to find the 0th term. So we're going to take away 1. So 9 take away 1 is 5. So the 0th term is 5. And the 0th term just tells us what to add on to the 4n. So 4n plus 5 will be our answer. When something is squared, you times it by itself. So another way of writing this is 6x to the power of 7 times 6x to the power of 7. The 6's can go together, and the x to the power of 7's can go together. And 6 times 6 is 36. And x to the power of 7 times x to the power of 7. When you times powers, you add them. So 7 plus 7 is 14. Something else you could have done is just squared the 6 to make 36. And one of the rules is that if you have a power on the inside of a bracket and a power on the outside of the bracket, you multiply them. So 7 times 2 is 14. First thing I can do with this question is write it as a fraction, because divide just means over. So we're going to have 42 times 10 to the power of 11 over 7 times 10 to the power of 2. And we can actually split those fractions up. So we've got 42 over 7 times 10 to the power of 11 over 10 to the power of 2. And you can see we're just doing it separately. So 42 divided by 7 is 6 times, and then with dividing, or as a fraction, when we divide powers with the same base, we take away the powers. So 11 take away 2 is going to be 10 to the power of 9. So it's going to be 6 times 10 to the power of 9. So we're told the length of this rectangle is u, and the width is u plus 2. Doesn't matter which way around we do it. And we're told the area is 80. So we can actually write an equation from this. So u times u plus 2, so that's the length times the width, is equal to the area, which is 80. So let's expand this. And what we're going to do is we're going to put everything to the same side. So all I'm going to do here is subtract 80 from both sides. And so we've got u squared plus 2u minus 80 equals 0. Now we're going to be using quadratics, so we're going to factorise this. And so we need two numbers that add together to make 2 and times together to make minus 80. So I'm going to put my brackets out. So we're going to have u at the start of the brackets, and let's have a think. So it's going to be 8 and 10, and one of them will be positive, one of them will be negative. Well, to add them together to make 2, the 10 will have to be positive, and then the 8 would have to be negative, and then minus 8 times 10 is minus 80. Okay, last thing is we get each of our equations equal to, sorry, each of our brackets equal to 0, so we can solve them. Let's just do this in normal colour. So u minus 8 equals 0, and let's solve that. And so we're going to add 8 both sides, and we've got u equals 8. And we're going to do the same for this right hand bracket, so u plus 10 equals 0. Get our lines in, and take away 10 both sides. So u equals minus 10. Now it might get confusing because it says find the value of u, but a length needs to be positive. So this minus 10 is not the correct answer. Our correct answer will be 8. And we can actually check this, because if I fill in the value of 8, so we can have 8 at the top here, and 8 plus 2, which is 10. 8 times 10 is 80. So we know that we've got the right answer. First thing we notice is that there is a square here, so we can work out what this length is going to be. It's also going to be 40 centimeters. And whenever we're working out the area of a shaded area, we're normally working out the area of two shapes and subtracting one from the other. And this question's really no different. So we're going to start off working out the area of the square. And all we need to do now for that is 40 times 40, which will be 1,600 centimeters squared. I normally only put units in our answer. The next thing we're going to do is work out the area of the circle, but to do that we need to work out what the diameter of the circle is, and if you notice that the diameter of the circle is just 40 degrees. It's the same as the width of the square, or height of the square. So if the diameter is 40 degrees, the radius would be 20 degrees. So for the circle, for the area of the circle, we're going to do pi times the radius, which is 20 squared, and 20 squared would be 400, so this will be 400 pi. This question's asking us to leave it in terms of pi, so we're going to do that. Now next we're going to work out the all of the corners, so that includes these 3 here and this one. So I'll say, like, I don't know, 4 corners. Just try and explain to the person marking my exam what I'm doing. And to do that, we're just going to do the square, take away the circle. So 1,600, take away 400 pi. Now we can't actually do anything more than that. That is our answer. So it's just, we just leave it at that. And to work out just the shaded bit, which is this bit here, they are 4 equal amounts that we've got for these corners. So just one corner, which is the shaded bit, will be the 4 corners divided by 4. Now we've got a kind of fraction here. We can divide all of the terms by 4. So that will leave 1 at the bottom, 100 pi here, and this will be 1,600 divided by 4 is 400. So we're just cancelling the fraction, and actually we leave it as 400 minus 100 pi, and that indeed is our answer. You can't simplify that any further. There are a few different ways you could answer this question. I'm going to do it with a tree diagram, but you didn't need to draw a tree diagram to answer this question. So we've got our first tree, which is our first bus, and the choices are male and female. And we've got our second kind of branch, I suppose, and it's still male and female. and this is our second bus. So the property of male on a first bus is 9/15, and therefore the property of female is 1 minus 9/15, which would be 6/15. Male on the second bus is 7/15, and so female would be 8/15, because they need to add up to 1. And it's independent, so these will be the same. And the question is basically asking what is the probability that both will be female. So to have both female, we need to have gone down this line at the start and then this line again. Okay, so looking at the fractions along the way, it's 6/15 and 8/15. The word "and" in probability means times. So whenever you're finding the probability of getting to an outcome, so this outcome will be FF, because they're both female, you are multiplying the fractions that you go across. So it would be 6/15 times 8/15. So 6 times 8 is 48, and times the bottoms, 15 times 15 is 225. Now you can actually cancel that down. So what you can do is you can divide top and bottom by 4, and that will give you 16. Is it 4? No, you can divide top and bottom by 3, and that would be 16/75. So either 48/225 or 16/75. So here we're given a standard form number, and we're asked to make it an ordinary number, which is just a number you type into the calculator. So we're going to start off by writing the decimal, which is 6.2, and we're going to shift that decimal point somewhere that it will be the actual number rather than standard form anymore. First thing to point out is we look at the power. If it's positive, it means that our ordinary number is going to be a big number. If it's negative, it means it's going to be a very small number. Since this is positive, we know it's going to be a big number. So we're going to do 4 jumps, because there's a power of 4, to the right to make it a big number. So 1, 2, 3, 4. So the decimal point is going to be here. And we're going to fill in the jumps with zeros. So 0, 0, 0. So our new number is going to be 62 with 3 zeros, or 62,000. Now it's important to realise that we're actually shifting the numbers, not the decimal point, but it's a lot easier to move the decimal point in our working out. Something we know about rectangles is opposite sides are equal. So these two will be equal. And these two will be equal. And you notice now that we've got simultaneous equations. So what I'm going to do is get the coefficient of the y the same. And I'm going to do that by multiplying everything in the second equation by 3. So we get 6x plus 9y equals 123. And I'm just going to write in the first equation underneath, because with simultaneous equations we work downwards. Now looking at the signs, they are the same, and the s in same is the s in subtract. So we're going to subtract going downwards. We're just going to subtract going downwards. So 6x take away 3x is 3x. 9y take away 9y is nothing, which is good. That's what we need. And then 123 take away 93 is 30. We're going to get our solving lines in, and we're just going to divide by 3 both sides. So we've got x equals 10. So we know what x is, but we need to find out what y is. So what I'm going to do is I'm just going to pick one of the equations. I could pick the 2x plus 3y equals 41, and just substitute the value of x in. So 2 times, instead of x, it's times 10, plus 3y equals 41. So it would be 20 plus 3y equals 41. Get my solving lines in. And we're going to take away 20 both sides. So we've got 3y equals 21. And then we're going to divide by 3 both sides if I don't run out of room. So y equals 7. So we've got x equals 10, y equals 7. Now I could check that with the first equation as well. So 3 times 10 is 30, 9 times 7 is 63, 30 plus 63 is 93. So we know we've got it right. So we're asked to express TQ in terms of P and Q. Well, we've got another Q here, because all of these are congruent parallelograms. And we have a P there. So if we're starting at T and getting to Q, we can go along this path here and down this path here. So we're going backwards down Q, in fact backwards down 2 lots of Q, and then the correct way down P. So it's either minus 2Q plus P or P minus 2Q. What I'm going to start off by doing is rearranging this equation so that it kind of matches this one. So I'm just going to write it down. And we want the n to be minus 2. So what I'm going to do is I'm just going to put my rearranging lines in. And we're just going to add 10 to both sides. Now, we've already got this line drawn for us on this graph. And so all we need to do is draw this line. So we've got y equals 10x squared plus 8x minus 2 drawn for us. We just need to draw this line, which is y equals 10, and see where they cross over to find the solutions. So y equals 10 will be all the way up at the top. Let's just make sure I get it nice. There we are. I need to move that up a little bit. There we are. And let's read off the values that that gives us. So it comes down here, and it comes down here. So the values it comes down to are minus 1.6 and 0.8. And those are our solutions. So here we're given a right angle triangle, and the question involves 2 lengths and angles, so we know we could be using trigonometry. So let's start by labelling our sides. The one opposite the right angle is the hypotenuse, the one opposite the marked angle is the opposite, and the one between the right angle and the marked angle is the adjacent. Now notice the hypotenuse doesn't have a number or letter next to it, so let's get rid of that. Next thing we do is draw our trigonometry triangles. So we've got SO, Ca, Toa. Now we've crossed out the H, so we're not going to be interested in the SO or the Ca. So it's going to be Toa. Toa is short for tan the angle equals opposite over adjacent. The angle is 60, so it's tan 60 equals x over 1. And so now here we're looking for the exact value of x. So if I times both sides here, let's just get our solving lines in here, and times both sides by 1, or just get rid of the fraction, we end up with x equals tan 60. Now you need to know off by heart what tan 60 is, and we can work it out just briefly by drawing a right angle triangle. Sorry, not a right angle triangle, an equilateral triangle. So that is going to be 60 by 60 by 60. And we're going to put all the lengths around the outside as 2. And what I'm going to do is I'm going to cut it down the middle. And I'm just going to cut it into half. And so the length at the bottom will be 1. And using Pythagoras, we've got to work out the length here. It's going to be 2 squared, which is 4, take away 1 squared, which is 1, will be 3, and then square root it would be root 3. So we know that's going to be root 3. So looking at labelling the sides here, just pick a colour to make sure it's nice. So we've got the hypotenuse here, we've got the adjacent here, and then the root 3 will be the opposite. And so we're looking for tan 60. So tan, as we know, is the opposite over adjacent. And so tan 60 is going to be the opposite, which is root 3, over the adjacent, which is 1 in our diagram there. So tan 60 is equivalent, it's the same as root 3 over 1, or just root 3. For us, you can complete a unique version of this paper by going to our OnMaths site. OnMaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.